Ladies and gentlemen, thanks for joining us again for the second session of the BeConnected webinar. I'm your host, Neha Dubey. We are going to have an informative webinar on the importance of data in energy transition. Here to speak with us, we have Dr. Diana K. Grohr, Director of Research and Development at NOV. Dr. Grohr has a keen focus on the dynamic and critical realms of oil and gas and energy technologies. Her work encompasses an extensive array of technical subjects spanning upstream and midstream oil and gas production, processing, compression, and transmission. Her expertise extends into ever-evolving fields of renewable energy, technology, and hybrid energy system. Before handing the stage to Dr. Grohr, I would like to make an announcement that at the end of the presentation, I'll initiate a short question and answer portion for Dr. Diana to answer questions from the audience. Please send in any question you'd like to her as session progress. You can do this by using the Q&A window by typing the question in and sending them across. I'll curate these questions and hand a few of them over to Dr. Diana when she reaches the end of her presentation. Also, if any of you encounter any technical issues during the webinar, please return to the top of the virtual lobby where we can have the technical assistant from vFairs, that's the hosting platform, to help you out. Now, without any further ado, I'll let Dr. Diana to take over and start the webinar. Over to you, Dr. Diana.
Thank you, Neha. Good morning and good afternoon, and I believe also good evening to some of you. I'd like to talk today about data science and simulation and the work we're doing at NOV, highlighting the importance of data in the energy industry, specifically in energy transition as we move from conventional oil and gas production and products over to renewable generated energy and products. Let me forward my slide here. So NOV is an equipment supplier. The way that we look at it within the oil and gas industry is that there are operators at the very top. There are oil field services companies and oil field contractors, also renewable energy contractors. And then down at the bottom of the food chain are the OEMs, and that's where NOV sits. So NOV is split into two organizations. The first organization is the Energy Equipment Organization. These are long cycle projects, specifically drilling rigs, offshore installation vessels for wind turbines. And then we also have our second product area, which is energy products and services. These are short cycle projects, specifically things like fiberglass systems, and also our digital and data offerings through a subsidiary called MD Todco. I know that corporate organizations can be a little complex for those of you who are trying to navigate them. So I wanted to give you a little bit of an overview of where things fit within NOV. Within the Energy Equipment Group, we have rig equipment and marine and construction. Marine and construction is guided by our Gusto MSC group. Gusto MSC develops vessels specifically for wind turbine installation and offshore oil and gas drilling activities. We also have a fluid motion systems group that has quite a few different OEM brands that we represent. We also do subsea production systems, specifically work that is done offshore, subsea, in the North Sea and also Gulf of Mexico. In our energy products and services divisions, we also have a downhole group where we develop bottom hole assemblies, downhole tools, completion tools. We also have our MD Todco unit, which is what I'm going to talk about a little bit more today. And I realize that this is very complex, but I put this in front of you just in case you're trying to navigate NOV or any other organization that may be an OEM or a manufacturer and is offering those services to the energy industry. At a glance, NOV is an organization of about 32 to 33,000 people. We have 554 global facilities in 62 countries. So there's a good possibility that wherever you are in the world, you've seen an NOV logo, or there is an NOV location that's near you. We are about $8.1 billion in annual revenue, and $707 million in adjusted EBITDA for the last quarter. What I'd like to talk to you about today is our data science and simulation organization that is within research and development in NOV corporate. That services the MD Todco business unit that I mentioned earlier. The way that we are organized is through our Chief Technology Officer's office. Our Chief Technology Officer is David Reed. He is both our CTO and our CMO. I report to him, and then as part of my responsibilities, I look after data science and simulation, which is the group of gentlemen that you see in this slide. Each of them are subject matter experts in their fields. We are always looking to expand this group. So if you're a PhD, if you're interested in data sciences and simulations, feel free to reach out to me. We are always looking for qualified people to join our organization. And as you can see, they have varied backgrounds, lots of chemical and mechanical engineers, electrical and industrial engineers as well. So what do we offer? As an organization to provide services within NOV, we offer structural, fluid, and data science analysis. Specifically finite element analysis. We do a lot of work in vibration and harmonic analysis because in the oil field and in the energy industry, there's usually something moving. There's always something moving. So we do a lot of fitness for service testing. We do a lot of stress analysis, and we also focus in on additive manufacturing. Additive manufacturing was something that was really, really interesting to us about 10 years ago. It has since kind of changed its direction and focus, but we're still using it for quite a few of our products. So if you're an additive manufacturing expert, do not worry. We still use the products in our generative design process. Through our computational fluid dynamics offering, we offer flow and pressure drop analysis, mostly erosion monitoring. Both erosion and corrosion are things that work against us in the oil field and work against us in energy transition. We do a lot in pump dynamics. We also provide system level simulation and fluid thermal analysis. On to data science. So data science, that group offers a lot of work in artificial intelligence, which I will show you in a little bit. We offer cloud services. We are certified in Amazon Web Services. We also do a lot in machinery prognostics and health management and signal processing. Sensor analysis and sensor fusion is something that's incredibly important to the energy transition industry. So when you look at energy, the importance of data cannot be understated. And that data comes from our sensors. We are an OEM for sensors, so we build a lot of them ourselves and install them on our own equipment. Those sensors have to be incredibly robust. They have to be environmentally tolerant. They also have to be tolerant of the personnel and the people that are installing them in the energy industry and in the oil field. What's interesting about sensors in the oil field is that they all have to last at least 5 to 10 years. That's a very, very long time for an electronic piece of equipment to last. As you know, things are obsolete very, very quickly in electronics. We are behind in the oil industry. So bringing those new products and services to the oil industry starts with my team and their analysis and data science. So how do we do projects? We do projects for lots of the organization. We do about 20% of our projects are for wellbore technologies. And I point this out because these are done in collaboration with third parties. We collaborate an awful lot. We spend time with our suppliers, we spend time with our vendors, and we supply lots of products and services, as you saw in my prior slide. We've supplied over 63,000 hours of engineering to the organization. So when we look at our computational fluid dynamics offerings, some of the biggest impact we have are to improve fluid flow understanding and create cost-effective design iterations. In the oil field, cost is incredibly important. There are different cost thresholds. When we look at land drilling, the cost thresholds are much, much, much lower, and their margins are slimmer, so they're not quite as tolerant to costs for analysis as offshore is. I do want to point out geothermal particle drilling. This is a new technology that we have intellectual property on that we're working on right now with a couple of third parties. This actually shoots ball bearings through the end of a drill bit and churns up the rock at the bottom of the hole. This allows us to drill faster, it allows us to drill cleaner, and it allows us to understand the drilling process better because it's more controlled than it would be with a regular drill bit. Another project that I'd like to point out, especially in the context of energy transition, is carbon capture. Carbon capture is a very, very big topic right now, and the data that comes from carbon capture systems is not currently well characterized. So carbon capture is an old technology, but in our particular applications, it's a new technology. So the oil field industry has been capturing carbon for upwards of 20 to 30 years. But what we've been doing is capturing carbon off of a wellhead. We have not been capturing carbon off of post-combustion activities. So what's interesting about that is now the carbon capture systems are fouled. We have a lot of extra products in the exhaust streams that we have to take care of. And the analysis that we do has shown us that we can handle up to a certain amount of NOx, nitrogen oxides, and a certain amount of sulfur dioxides without after treatment. This is incredibly important because that allows us to take hardware out of the system, and we've learned that through our data analysis. If I look at our finite element analysis offering, we provide capabilities across the organization in drilling, which is the activity and the product that you'll see to the far left. This is a pipe handling system for drill pipe. We also do a lot of data analysis on separation systems. Those separation systems are incredibly important to the oil field industry because it's how we remove the water from the oil. When you drill a well, you're always drilling into a combination of water and oil products and gases. So you have a three-phase system, and it's incredibly important to be able to separate those products without losing anything, and then take out the water because we don't want to produce water. Water is not a value-added product. It's not a commodity. And so we want to pump that back down whole. In wind turbine installation, this is an incredibly complex, data-heavy activity. We are looking at installing wind turbines, and we do install wind turbines with our cranes and our vessels in the North Sea. The wind loading on these very, very large cranes is sometimes very, very harsh. And we wouldn't know that without the data that we have from instrumenting those cranes. Moving on to downhole, what you see in front of you on the fourth picture from the left is a blowout preventer. For those of you that may or may not be aware in the oil field, there have been a couple of movies that have shown what happened in the BP oil spill in the Gulf of Mexico. The movie highlights the Macondo well. And what happened in the Macondo well is what I'm showing you in the animation. That's the fourth animation from the left. What happened was the shears were not able to shear the pipe because the pipe was not centered appropriately. That is why we had the big failure in the Gulf of Mexico. So that analysis is something that we do. That analysis is very important to the oil field because it's about safety and it keeps our people safe in the oil field. We also manufacture and install solar panels. NOV makes a product that is an actuator for solar panels. As some of you may know, solar panels have to be pointed at the sun in order to be most efficient. The challenge with that is actuating the solar panel. And one thing that NOV does well is design actuators. So what we do is we design an actuator that allows us to point the solar panel at the sun throughout the day. That changes the direction that the solar panel is pointing relative to the wind. So we also have wind loading analysis, vibration analysis, and stress and strain that we have to account for in our energy transition products. On to data science. Data science is a highly collaborative group. We work a lot with our coil tubing systems group and also our other automation groups across the organization. The model that I'm showing you here performs a really important role when we automate these systems, okay? So the reason that the data is so important is that we're trying to move people out of the red zone. We're trying to move people off the rig and away from the wind turbines. In order to do that, we have to understand what's going on and we have to have the data. We use probabilistic and deep learning models. We use event probability calculations, and we are implementing these systems that you see in front of you for real-time closed loop control with PLCs. We have a product called Max Completions. Max Completions is a very forward-thinking product, but it's all data-driven. There is no interaction between the operator. No decisions are made by the operator. It's all done by the automated system. Another project that I wanted to highlight for you is sound analysis. Sound analysis is incredibly important when you're looking at high frequency vibration. We have created multiple products using time frequency domain analysis for our oil field service technicians and our wind turbine service technicians. So what that allows us to do is actually calculate and capture vibration with your cell phone. Okay, so we're slowly moving toward new types of tools in the oil field. We're slowly moving toward new types of data collection in the oil field. And a lot of those data sets allow us to automate, as I showed you in the last slide. Another project that we're working on is rig load detection and emissions management. So one thing that has become ubiquitous across the industry lately is the focus on emissions. carbon emissions, currently CO2 and methane emissions, are incredibly important because what we do not want to do is harm the world around us. We do not want to harm the atmosphere. We do not want to make it harder for humans and other animals to breathe. And so what we're doing with this project is developing an engine emissions management model with MD Todco. This is our data science and services group within NOV. So what we're doing is we're taking time series data along with an activity type and a rig state label from the operator, and we're creating a load prediction model. What that load prediction model allows us to do is predict the load that the drilling rig will need from the power plant about 10 minutes in advance. And the reason that we can do that is because we have good data. If we didn't have good data, we wouldn't be able to predict that far out in advance. And therefore, we wouldn't be able to provide our operators decision tools in a timely manner that allows them to think about it. First of all, humans need time to think, and then they have to make a decision, and then they have to take an action. That takes time. So what we're doing is we're currently training the model with both engine operating and emissions data and rig operational data. And what that allows us to do is load balance on the generator versus the power plant versus the drilling rig itself, convert the fuel mass with an empirical model to our emissions model, and then calculate those emission savings. This is our predicted model along the bottom here. Notice that we're over predicting the amount of power that we're going to need. That's because of safety factors. One thing that I have come across when I work with data science teams is that they're so incredibly precise. They do an incredible job of being focused in on the data that is happening and the action that needs to happen at that particular second in time. That's not necessarily representative of what the operator will do. That's also not representative of what the equipment will do. Sometimes equipment takes time to actuate. So in this particular model, what we've done is we've taken our time series data and we've overcorrected with over predicted with a safety factor at 10 minutes time. And what that allows us to do is give the operator time and give the equipment a little bit of flexibility when we are able to evaluate the data that's coming out of the hole. We are also currently evaluating the impact of downhole geometry and geology on the model. Geology is an incredibly hard science. And the reason is that the rocks downhole are not consistent. So every time you hit a new geology type, your data model changes. So that's something that we're looking for expertise on. We're spending a lot of time on it. And again, I'd like to highlight the importance of having really, really good data in order to predict. We can't predict and move forward unless we have the right data sets at the right time so that the human in the loop can make a decision before we go to closed loop control. Another project that we're working on that we're really excited about is the Azure OpenAI API. And what that is a custom data chatbot that we have developed internal to NOV to search all of our data sets. The original data is mixed structured data and unstructured data. It's free text in text boxes. Sometimes the data sets don't have the right description. Sometimes the data sets are not in the right place. So what we did was we took unstructured documents and searched them with Azure's cognitive search agent. That data is then queried with an SQL search agent, and our state-of-the-art GPT-4 model is used behind the scene. What this allows us to do is figure out where everything is. When you get to be a 100-year-old company like NOV, there's data everywhere. And a lot of it is unstructured. When you have someone retire, sometimes they just leave a laptop, right? So all of the data, you know it's in the laptop. Where is it? What is it? What does it look like? Or you have a web-based portal like Team Center, which is what we use at NOV, but that data is still not structured and it's still not in the right place. So GPT-4 and our OpenAI chatbot is helping us query this data and return the right information so that our engineers can make the right decisions. And that's all I have for you this morning. I'd like to open it up for questions. Thank you.
Wow, what an insightful session that was, Dr. Diana. So
Thank you,
we have
Neha.
a couple of questions for you right now. I'll be pulling it out for you. So the first question we have over here is, how does the quality of data affect decision-making process in the energy sector, particularly in the areas like investment, infrastructure, development, and risk management?
Right. So all of the data, please think of data as an evolving tool set. It's incredibly organic. It moves around from person to person to person. And please know that when you create data and you create a tool or an application for a company like an NOV, for any other company in the energy sector, that data is eventually going to make it to places that you did not know it would go. So be very precise, be very specific in what you share. And the reason is that sometimes that data will end up with an investment committee, and that investment committee will use your data and the decisions that you've made in order to decide whether or not to invest in a startup, whether or not to do mergers and acquisitions, whether or not to move forward with a project. And also, risk management is incredibly important. Currently, there is an entire ecosystem of insurance companies around energy transition. They are hungry for data and they are looking for opportunities to collaborate. The challenge is getting them the right data at the right time in the right context so that they can write insurance policies so that my company can go out and drill wells. It's an incredibly imprecise science. So when you, as a data scientist, provide data to engineering, please know that it's not going to just stop with engineering. It's not just going to stop with your IT infrastructure people. It's going to continue moving throughout the organization and probably through other organizations. And if you traced the path of your data, you would see this winding road that eventually ends up with on the desk of decision makers who make very big decisions about where we're going in energy transition.
Thank you for answering that, Dr. Diana. I have a lot of questions for you coming up. So the next question is, do you have a data governance team in place? How is the data governance managed currently?
Yes, so we do have a data governance team in place. The data governance team is a combination of internal resources and external resources. So NOV as an OEM, we like to partner. And the reason we like to partner is we know we can't be subject matter experts in everything. So the data governance model currently is evolving. It is really centered around security of our data. The oil field industry, because it's such a big industry and because there's so much money involved, is constantly being infiltrated is probably the right word. And I'm not sure I want to use the word attack, but I'll go ahead and use it anyway, by foreign actors. And in order to stop those activities, we have to have a very, very robust data governance model in place. It includes everything from not using USB drives to using a completely cloud-based infrastructure. We're a Microsoft Office 365 house. We also have a variety of tools for logging in and logging out of different data sets. We also have a very, very restrictive data access policy. So if you need to know about a certain data set in NOV, you need to ask for access to those data sets. And then it will go through a governance review, and that governance review team will then decide whether or not you actually need access to that data. Please note that it's not automatic and it's not something that happens overnight. So when you're planning projects, please take the time to build in time for those data governance reviews in your architecture.
Thank you. Thank you. The next question I have for you over here is, can you throw light on how data science is helping reliable energy more reliable as a continuous source of energy?
So data scientists are the front of the vector. So our data scientists are currently the spearhead that allows us to move energy from one place to another. It's incredibly important to have good data. It's incredibly important to have good data scientists. And it's incredibly important for those good data scientists to collaborate with your equipment subject matter experts. Okay, so they are the beginning of how we move energy. Because it's all based on data. For a while there, everybody was excited about data lakes. Everybody was excited about data ponds. Everybody was excited about that. We're not finding that that is the best direction for the energy transition. And the reason is that that's because we have so many different types of data. So reliable energy is moved from one location to another location only after the data science is complete.
That's great to know. The next question I have for you, Dr. Diana, is how much of unstructured data is processed versus structured data?
I would say it's probably 70-30. So probably what we look at now is 70% structured data and 30% unstructured data. Now, that's not necessarily a good thing. And the reason it's not a good thing is because there's so much information, so much more information in unstructured data. But we're just now developing tools and being able to interrogate that unstructured data. So we're getting better at it. But I would say we're definitely not there yet.
Oh, got it. So data cataloging is the new trend right now. We see all over the data cataloging is a new buzz. So we have one question for you for that. Do you have a data catalog solution in place?
We do, that I have seen. Now, whether or not it's a prototype, I do not know. There is a couple of different groups within NOV that are looking at data cataloging solutions, including our CIO's office. So the challenge is that because of the complexity of the NOV organization, and I showed you all the business units, I showed you all the brands and the groups, they all have their own data sets, and therefore the tools for data cataloging need to be custom built for each of their types of data sets. Now, I like to simplify things. and say time series data is time series data, but that's not necessarily true. There is a lot more information included when you can catalog the data. But yes, that is a buzzword right now. That's something that everybody's looking at. We have lots of operators looking at that as well. And the reason is that we transfer data back and forth from our servers to our operator servers almost continuously.
So, Dr. Diana, as you know, cost plays a vital role when it comes to implementing a certain technology. So my next question from the audience is how to reduce the cost of implementing AI and data projects?
Oh, that's a really good question. And I'm not an AI expert. What I would like to see as somebody who leads a data science organization is development on a case-by-case basis. As I said earlier, NOV is a very complex organization. The challenge is that we don't have a one-size-fits-all model. So what I like to see is I like to see bespoke solutions for specific challenges that we're facing either in the field or in the office. Those bespoke solutions seem to be the most cost effective. When you start trying to take multiple projects and jumble them together into a larger solution, you get inefficiencies, you get ineffectiveness, you lose the viability of the subject matter experts and their engagement and involvement in the project. So again, in my role in research and development, I like to see specific solutions on a case-by-case basis. That seems to keep the cost down. You cannot take a wind turbine solution data model and apply it to an oil derrick. You just can't do it. That's two different. The operations are two very different. The cost profile is very different. The risk profile is very different. And it doesn't, in my experience, it's not very effective.
Got it. If you're comfortable in answering a few more questions, can I go ahead?
Yeah, absolutely, please.
Sure. So the next question is also on AI and data science. So can AI and data science work hand in hand partially to drive important decision and complex problem in energy industry?
I hope so. I certainly hope that AI and data science are working hand in hand, because if they're not, we're doing something wrong. So artificial intelligence from the oil field's perspective has not moved further than what I saw you earlier in terms of generating searchable content, generating content that is digestible by a human. That's where we're going currently. The engine emissions model that I also showed you, the graph that was along the bottom that had all the peaks and valleys, that was a drilling rig model. That was generated by AI, but the data set that it was using to generate that model was selected by people, right? It was selected by my data scientists. It was selected by the people that are working on those projects. So what I like to see is I do like to see them work hand in hand. Things tend to work faster. I am an AI user in my own time. I am an open AI user. I love it. I use it all the time. Makes me more efficient and more effective. But if we're not using AI in parallel with the data science models that we already have, then I think we're doing something wrong.
Right, absolutely agree. The next question I have for you is, how are you managing the master data governance in your company?
Oh dear, master data governance is a challenge. So we are currently doing it a fairly conventional way, which is with roles and rules. and through access requests. So the master data set that we have, like for the OpenAI search engine that I showed you a couple minutes ago, that master data is sitting in Team Center. Team Center is hard. It is an incredibly challenging tool to navigate. It is an incredibly challenging tool to get data out of. And so what we like to do is we like to keep the master data in one location and then provide role and rules-based access to that data. Luckily, now that we have cloud-based solutions, we can actually leave that data where it is and we just query it. I personally don't like to see people move master data around because it makes me nervous. It makes me nervous that we're going to lose something. It makes me nervous that we're going to interpret it incorrectly. It makes me nervous that it won't be there for the next project.
Right. Okay. So I have more questions for you.
Yes, please.
What is your advice for companies who want to embark on a data science project?
How big is the company? So what I like to see in companies of any size, be it a startup, be it a well-established third party, be it a technology holding company like NOV, is I like to see us start small. And the reason I like to see us start small is because then you can build out those efficiencies and you can answer the questions that would normally get stuck in the rigmarole of a big project, right? So once you build a project out and it starts getting very, very, very large, you lose those efficiencies and you lose effectiveness and your risk goes way up. So I like to see data science projects start small with a very, very focused solution in mind. As I showed you a little bit earlier in our OpenAI model, that was just for searching drill bit sizes and drill bit types. That's the kind of data science that I like to see.
That's a very helpful advice, Dr. Diana. The next question I have for you is, how can data-driven technologies such as smart grids and IoT devices help improve the efficiency and reliability of energy systems during the transition?
Anytime we can take the human out of the loop, I gain efficiencies. That's just the way it is. We see that with drilling operations all the time. We are the first company to provide a completely robotic and automated drilling rig to the market. It has 5 robots on it. It has a top drive and iron roughneck and 3 conventional robots like you would see in an assembly plant, like for automotive, for the automotive industry or the aerospace industry. Anytime I can take a human out of that decision loop, I gain efficiencies because humans take time to process data. And AI solutions, process GPUs, they move so much faster than my humans do in the field, that it's absolutely imperative that we use these kinds of IoT devices, that we use IoT strategies in our operations. It's imperative that we transfer that information from industries that are out in front of us, like the EV industry. The EV industry is 10 years, 20 years ahead of the oil and gas industry. They're also 10 years, 20 years ahead of wind turbines, right? So if we can transfer those best practices into the oil field, remove the human from the loop, have hardware in the loop, closed loop control, then I can start recognizing the efficiencies and the real benefits of my computational systems.
Got it. Next question is again for AI. AI is a used reminder, I guess. So how AI can help to detect the power of theft and energy fraud? Is there any automation tool for it?
So far, I have not seen, there may be a tool available, but I have not seen it and I have not used one. Intellectual property theft is a huge problem in the energy space. And the reason that energy is targeted is because there's so much money involved. And the risk is so high. And the developed subject matter expertise is so incredibly important to consistent and safe operations. And also we're working with people. And unfortunately, people still think that when they work for a company and they develop something in their brain, that it belongs to them. I have news for you. If you are taking a salary from a company and you develop intellectual property while you are taking a salary from a company, the company owns that intellectual property. I guarantee you it's in your contract. You cannot walk out the door with that intellectual property, go to a competitor, or start your own business. You cannot do that. I will come after you. So what we need to do is we need to make sure that we educate, especially our engineering resources, on data governance, as we discussed earlier, and on intellectual property ownership. We have rolled out a program within NOV to educate people. Like I said earlier on the data governance question, we've locked down USB ports. We've locked down access to the cloud. We have role types, rules, etc. But that doesn't mean that that takes the burden off the individual to not steal. And so what is happening currently is we're starting to see tools come forward that can help us search access types and who's accessed that information. We just have not rolled out one for R&D currently. That's a good idea. I'm going to write that down and I'm going to pretend that it's my idea and we're going to go do it.
Yeah, absolutely. The next question I have for you is, what is your enriching successful project in your career around data science?
So my most enriching project around data science is one that I'm working on now. And I believe that's because the data science capability has really started to accelerate, right? So we're seeing data science models that are much more complex. I am an engine engineer by training. I'm a combustion engineer. First principles combustion models are not typically something that we run in real time. They take a long time to run. They take a GPU. They take lots of computational power. But with data science as it's evolving currently, what we're being allowed to do is use AI to develop reduced order models and machine learning models. And those are allowing us to actually loop in hardware. So what I'm doing now is I'm working on hardware in the loop, closed loop control of equipment in the oil field, specifically the power plant, the diesel engines. And that is allowing me to characterize their operation, operate them more fuel efficiently, operate them safer. And then also it's allowing me to capture and characterize the emissions data. And that's new. So this is probably This is probably my most fulfilling project so far. I hope they continue to be fulfilling. I hope that the next project is even more interesting.
Thanks a lot for sharing that insight, Diana. I have the next question again on AI. How does AI handle large database?
Oh dear. We have applied AI in NOV to what I would consider small data sets. So we have not taken an AI model, whatever it is, and applied it across the board to all of our data. That would be an incredibly inefficient way to do it. And so what we're doing currently is we're working on a project by project basis and ingesting that data as needed. And I would recommend that that's the approach that you take when you start off a project, is only ingest the data that you need. Now, you may not know what data you need. You may need different data eventually, but you'll discover that as you go along, that there is more data, that there's another data set. It's probably sitting on somebody's laptop somewhere in the world that you'll need to access. I would say access that data on a case-by-case basis, because what you don't want to do is waste the computational energy that you need. So I was having a conversation around AI with a couple of colleagues. If you do a Google search, it costs you 1 watt of energy. If you do an AI search, right, like a ChatGPT, OpenAI search, it costs you 5 watts, right? So it's 5 times more expensive to use AI than it is just to use Google. Now, I'm not saying AI won't become more efficient and more effective. It will, but please remember how much energy you're using. And in the energy industry right now, we're in a little bit of a crisis. We are not producing enough energy for the world's demand currently. There are 3 billion people in the world right now that do not have access to cheap, reliable energy in the world. So hopefully AI applied to those use cases can help us be more effective and more efficient. And we can get that 5 watt number down as we go.
That's the most useful information I had today in this session. One more question, then we'll move to the last one. What is your advice on ESG?
My advice on ESG, and I'll take it from the oil and gas company perspective, because those are my main customers. My perspective on ESG is we should have done it, and we should have done it 10 years ago. We should not be polluting our planet. We should be using appropriate social policies, appropriate governance policies to positively impact our environment. We should have been transitioning a long time ago. Specifically, we should have been transitioning in the early 2010s, before the oil market crashed in 2014. That's when we should have started this. If we had started earlier, we would be much further along. Right now, we're playing catch up, right? So right now, everybody is trying to roll out as many solutions as they can as quickly as possible. Now, what happens when you rush is you miss things and you develop those inefficiencies and you develop use cases that are not necessarily the kind of use case that you should be developing. So what I think about ESG is that it's evolving, and I think it's going to continue to evolve faster and faster and faster. And I want to remind everybody that when we talk about ESG, most people talk about the environment. They talk about carbon dioxide pollution. They talk about polluting the atmosphere. We're not just polluting the atmosphere, we're developing plastics. Those plastics are polluting our oceans. And there is an S and there is a G in there too. So we need to make sure that we're implementing the appropriate social policies and the appropriate governance. They all fit together.
True, absolutely. So I think I have a concluding question for the session. What is
Okay.
the one takeaway that you would like to leave our audience with today?
The one takeaway I would like to leave the audience with is that we're evolving. The energy industry is evolving, and we may be evolving in the wrong direction. I don't know, but at least we're evolving. We are doing the very best that we can with the resources that we have in order to transition to a cleaner, better future. And I want to remind everybody that when you see wind turbines out there, when you see solar panels out there, those are being invested in by oil and gas companies. So your ExxonMobil, your Chevron, your Shell, your BP are some of the biggest clean energy developers in the world. We far outpace those that are pure play developers like Ørsted in Europe. So I want to remind you that oil industries are quickly accelerating in the energy transition. We're trying to take technology that we have from the oil and gas industry and apply it to other forms of energy so that they can be just as efficient and effective as we are with oil.
Absolutely. I think we are running out of time. So
Yes.
I just want to thank you for what an insightful session you have given us, Dr. Broad. So this time is to wrap up this session, but please do come back for our next session by Jared Campbell. He will share his valuable inputs on how we can democratize data governance. We appreciate you all being here and hope to see you all soon. Thank you, Dr. Broad. You're a lovely host of Peter that I have. Thank you.
Thank you so much. Thank you for the opportunity, and thank you for all listening to me for an hour.
Thank you, everyone. Bye-bye.